In the crucible of the Cold War, a desperate race for technological and ideological supremacy ignited a firestorm of innovation that would redefine the limits of human ambition. The Soviet Union's launch of Sputnik in 1957 had sent shockwaves through the United States, a stinging blow to American pride and a stark challenge to its scientific dominance. President John F. Kennedy, in a bold and audacious declaration on May 25, 1961, laid down the gauntlet. America would land a man on the moon and return him safely to Earth before the decade was out. It was a promise that seemed to many utterly impossible, a fantastical dream woven from the threads of science fiction. Yet for 8 grueling years, a nation mobilized its finest minds, its most dedicated engineers, and its most courageous astronauts, pouring billions of dollars and immeasurable human effort into a singular monumental goal. The world watched, holding its breath, as the Gemini and Apollo programs pushed the boundaries of what was conceivable, each mission a perilous step closer to the lunar surface. The stakes were immeasurable. National prestige, scientific leadership, and the very soul of a nation locked in a global ideological struggle. Failure was not an option, but success felt like a miracle perpetually just out of reach. A long, arduous journey, fraught with peril, was about to reach its zenith. On July 16, 1969, at precisely 9:32 a.m. Eastern Daylight Time, the colossal Saturn V rocket, a towering monument to human ingenuity, roared to life at Launch Complex 39A of Cape Kennedy, Florida. With a thunderous bellow that shook the very ground and a brilliant plume of fire, it clawed its way skyward, carrying 3 men, Neil Armstrong, Buzz Aldrin, and Michael Collins, and the collective hopes of humanity into the vast expanse of space. Millions gathered near the launch site, their faces upturned in awe, while billions more across the planet were glued to their television sets, witnessing history unfold in grainy black and white. For 4 days, the Apollo 11 crew journeyed through the vacuum, a silent ballet of precision and courage, their voices occasionally breaking through the static of mission control, reporting on their progress, their anticipation palpable. Michael Collins orbited alone in the command module Columbia, a solitary sentinel, while Armstrong and Aldrin prepared for the most daring maneuver of all, the descent to the moon in the lunar module Eagle. The tension was almost unbearable, a global pulse quickening with every passing minute as the Eagle detached and began its perilous plummet towards the lunar surface. And then, after 4 days of travel, the moment of truth arrived, a descent into the unknown. At 4:17 p.m. EDT on July 20, 1969, a voice crackled through the speakers at Mission Control in Houston, Texas, a voice laced with the exhaustion of intense concentration and the profound relief of success. Houston Tranquility Base here. The Evil has landed. A collective gasp, then an explosion of cheers erupted in the control room, tears streaming down the faces of engineers and scientists who had dedicated their lives to this merry moment. Hours later, at 10:56 p.m. EDT, Neil Armstrong emerged from the lunar module, a ghostly figure in his bulky white suit against the stark alien landscape. He carefully descended the ladder, his boot touching the powdery regolith, and uttered the immortal words that would forever echo through history. "That's one small step for man, one giant leap for mankind." Buzz Aldrin soon joined him, and together they explored the barren, magnificent surface of Earth's closest celestial neighbor, planting the American flag, collecting samples, and leaving behind a plaque that declared, "Here men from the planet Earth first set foot upon the moon, July 1969 amperes. We came in peace for all mankind." The world watched, mesmerized, as humanity's greatest dream unfolded live. The impact of Apollo 11 was immediate and profound. Billions across the globe, transfixed by the flickering black and white images on their television screens, bore witness to an event that transcended borders, politics, and language. For a brief, glorious moment, humanity felt unified, connected by a shared sense of wonder and achievement. Celebrations erupted in every corner of the world, from bustling city squares to remote villages, a testament to the universal appeal of pushing the boundaries of human endeavor. The astronauts returned to Earth as heroes, enduring a brief quarantine before embarking on triumphant ticker-tape parades in New York, Chicago, and Los Angeles, hailed as pioneers of a new age. The moon rocks they brought back offered unprecedented scientific insights into the moon's formation and history, opening new avenues of research and inspiring a generation to look to the stars. It was a triumph of engineering, courage, and collective will, a definitive answer to Kennedy's challenge and a monumental statement about what humanity could achieve when united by a common purpose. But even as the echoes of celebration reverberated across the globe, a subtle, almost imperceptible discord began to emerge. Despite the overwhelming evidence and the global consensus, whispers of doubt began to surface almost immediately after the astronauts' triumphant return. For some, the sheer improbability of the feat, achieved so rapidly after Kennedy's bold promise, seemed too good to be true. In an era marked by Cold War propaganda and a deep-seated distrust of government narratives, especially following events like the Vietnam War, a small but growing number of individuals found it difficult to accept the official story without question. These initial doubts were often isolated, born from a general skepticism rather than specific evidence. People began to scrutinize the grainy photographs and video footage, searching for inconsistencies, for anything that didn't quite fit their preconceived notions of space or photography. Why did the flag appear to wave in a vacuum? Why were there no stars in the lunar sky? What about the seemingly parallel shadows? These were the nascent questions, often dismissed as fringe theories, that would slowly but surely begin to coalesce into a more organized and persistent challenge to NASA's narrative. What began as fragmented questions, dismissed by many as mere eccentricities, would soon coalesce into a formidable counter-narrative. The true genesis of the moon landing hoax theory, however, can be largely attributed to one man, Bill Kaysing. A former technical writer for Rocketdyne, a company that built rocket engines for NASA, Kaysing published a self-financed booklet in 1974 titled "We Never Went to the Moon: America's $30 Billion Swindle." Kaysing, who held a bachelor's degree in English and had no formal scientific training, argued that NASA lacked the technological capability to send humans to the moon safely, and thus faked the entire mission in a secret studio, likely in the Nevada desert. His book, filled with what he presented as anomalies in official NASA photographs and documents, captivated a segment of the public already predisposed to distrust government institutions. Kaysing's core argument was that the risk of a lunar landing was simply too high for the technology available at the time, and that the only way to fulfill Kennedy's promise was to stage the event. He meticulously laid out a case, albeit one based on misinterpretations of physics and photography, that resonated with a burgeoning anti-establishment sentiment, providing a tangible framework for the burgeoning conspiracy theory. And so, the seeds of a monumental doubt were sown, taking root in the fertile ground of public skepticism. Over the decades, these initial claims, fueled by Kaysing's book and amplified by others who followed in his wake, gained surprising traction. With the advent of the internet, the theories exploded, finding new life and new adherents in online forums, documentaries, and social media. The evidence evolved, with new supposed inconsistencies being discovered and old ones reinterpreted. The arguments became more sophisticated, or at least more voluminous, touching upon everything from the Van Allen radiation belts to the absence of blast craters, from the precise angles of sunlight to the physics of footprints in lunar dust. For proponents of the hoax theory, the enduring questions raised by these claims represent a profound challenge to established authority and a demand for transparency from powerful institutions like NASA. For many, it's not just about whether humanity landed on the moon, but about the very nature of truth, the reliability of official narratives, and the insidious possibility of a grand deception orchestrated at the highest levels. This persistent belief, held by millions worldwide, underscores a deep cultural distrust and a fascination with the hidden, the secretive, and the conspiratorial. As we embark on this journey, we must ask, what truly happened on July 20, 1969? And why, over half a century later, do these shadows of doubt continue to loom so large? For decades, the story of humanity's first steps on another world has been etched into our collective consciousness. July 20th, 1969, Tranquility Base, the Moon. Neil Armstrong, Buzz Aldrin, the Apollo 11 mission, a triumph of human ingenuity and courage. Yet for just as long, a shadow of doubt has persisted, a whisper that perhaps it was all an elaborate illusion, a theatrical masterpiece played out not on the lunar surface, but on a soundstage here on Earth. This theory, often dismissed, has nevertheless captivated millions, fueled by compelling visual evidence that at first glance seems to defy explanation. the architects of these claims are not always fringe voices. They are often thoughtful individuals who scrutinize every frame of footage, every photograph, seeking anomalies, inconsistencies, and what they believe are the telltale signs of a colossal deception. They challenge the official narrative with a barrage of questions, each one designed to erode our faith in what we thought we knew. And today we will present their most powerful arguments, allowing their alleged proof to speak for itself, before we journey into the scientific and historical context that offers a different perspective. Perhaps the most iconic and immediately perplexing image for many is the American flag planted firmly on the lunar surface. It appears to ripple, to flutter, as if caught in an unseen breeze. But how could a flag wave in the vacuum of space, where no air exists? This visual anomaly, a seemingly undeniable contradiction of physics, has become a cornerstone of the hoax theory, suggesting an atmosphere, and thus an earthly set. The truth, however, lies not in an unseen wind, but in ingenious engineering. NASA anticipated this very question. The flag wasn't simply draped from a pole, it was supported by a telescoping horizontal bar designed to extend outwards, giving the fabric a permanent unfurled appearance. The wrinkles and creases, the very folds that suggest movement, were simply the result of it being tightly packed during its journey, and the rigid bar holding it partially extended in the airless environment. On Earth, gravity would pull these folds out. On the Moon, they remained, creating an illusion of motion. The image, initially so disarming, becomes a testament not to deception, but to the meticulous foresight of engineers designing for an alien world. Another powerful argument against the authenticity of the lunar photographs points to the vast black lunar sky. Conspiracy theorists ask, where are the stars? In the airless void of space, with no atmospheric interference, surely countless stars should be visible, blazing brilliantly against the darkness. Their absence, they argue, hints at a studio backdrop, too small and limited to depict the true cosmic tapestry. Yet, this perceived omission is a fundamental principle of photography. The lunar surface, brightly illuminated by the unfiltered sunlight, and the astronauts themselves, clad in brilliant white spacesuits, presented an extremely bright foreground. To capture these elements correctly, the cameras like a Hasselblad 500 EL/70mm that documented the Apollo missions were set with very short exposure times and small apertures. These settings, necessary to prevent overexposure of the brightly lit foreground, effectively rendered the faint light from distant stars invisible to the camera sensor, much as stars are difficult to see in a brightly lit city on Earth. The human eye, with its dynamic range, might catch a few, but a camera, with its fixed settings, could not capture both the brilliant foreground and the distant dim stars simultaneously. The missing stars are not evidence of a hoax, but of photographic necessity. The play of light and shadow on the lunar surface has also drawn intense scrutiny. In many photographs, shadows appear to converge or diverge in ways that seem inconsistent with a single, distant light source like the sun. Theorists claim this suggests multiple light sources, much like a film set employs various lamps to illuminate a scene. If the sun were the only light source, all shadows should be parallel, they argue. This argument, however, overlooks the principles of perspective and topography. On Earth, we are accustomed to seeing parallel lines appear to converge at a distant vanishing point. On the Moon, with its undulating, uneven terrain, shadows cast by a distant sun will not always appear perfectly parallel to an observer, especially when viewed from an elevated camera angle or across a curved surface. The lunar landscape is not a flat plane. Craters, hills, and depressions all alter the perceived direction of shadows. Furthermore, the very nature of a photograph flattens a three-dimensional scene into two dimensions, which can distort our perception of depth and parallelism. The sun was indeed the sole significant light source, its vast distance ensuring parallel rays, but local topography and photographic perspective create the visual trickery. In one particularly infamous photograph, a rock in the foreground appears to have a distinct letter C, clearly visible on its surface. For many, this was the smoking gun, undeniable proof that the lunar landscape was nothing more than a carefully constructed prop, with objects labeled for placement by set designers. How else could a perfectly formed letter appear on a natural moon rock? The C rock, as it has become known, is almost certainly a photographic anomaly, a tiny imperfection on the original film negative or a stray hair or fiber that was inadvertently exposed onto the print. Such occurrences are not uncommon in film photography, especially with images taken in extreme conditions. The sea is not present in all versions or copies of the photograph, and its appearance is often faint, suggesting a localized artifact rather than an intentional marking on the rock itself. It is a case of pareidolia where the human brain perceives familiar patterns in random stimuli, fueled by the desire to find evidence supporting a preconceived notion. The universe, in its vastness, does not often label its rocks for our convenience. Upon inspecting images of the lunar module, both before and after landing, a curious detail emerges for the skeptical eye. There is no blast crater beneath the craft. Given the powerful descent engine used to slow the module's approach, many argue that a significant crater should have been blasted into the lunar regolith. Its absence, they claim, indicates the module was simply lowered onto a pre-prepared set, never having actually landed under its own power. This theory misunderstands the physics of lunar landing and the nature of the lunar surface. The lunar module's engine, while powerful, was throttled down significantly in the final moments of descent to avoid kicking up excessive dust and to conserve fuel. The engine's thrust was also diffused by the vacuum of space, meaning the force was not concentrated in a narrow jet as it would be in an atmosphere. The lunar regolith, a fine powdery material, is not like terrestrial soil. It's a loosely packed layer of pulverized rock. The engine's exhaust tended to fan out, blowing the dust horizontally rather than excavating a deep crater. Furthermore, the engine was cut off just before touchdown, allowing the module to gently settle onto the surface. The lack of a deep crater is, in fact, consistent with the engineering and physics involved in a soft landing on a vacuum-covered dusty surface. Perhaps one of the most persistent and dire warnings issued by hoax theorists concerns the lethal radiation of the Van Allen belts. These belts, discovered by James Van Allen in 1958, are zones of energetic charged particles trapped by Earth's magnetic field. Theorists claim that the Apollo astronauts would have received a fatal dose of radiation simply by passing through these belts, rendering a manned mission impossible without special, unrevealed shielding. However, this argument exaggerates the actual risk and misrepresents the Apollo trajectory. The Apollo missions passed through the thinner, less intense regions of the Van Allen belts, and did so very quickly, typically in less than an hour. The command module itself provided significant shielding. Its aluminum hull and the equipment within offered substantial protection against the lower energy particles. While the astronauts did receive a small dose of radiation, it was well within safe limits, comparable to a chest X-ray, and far below the threshold for acute radiation sickness. Extensive pre-mission planning and trajectory optimization ensured that the crew spent minimal time in the most intense regions of the belts, mitigating the risk effectively. The threat was real, but it was meticulously managed, not ignored. The perfect, crisp footprints left by Neil Armstrong and Buzz Aldrin in the lunar dust also raise questions for skeptics. On Earth, dry sand or dust typically crumbles, failing to retain such sharp definition. How then could such clear, deep footprints be left in the supposedly dry, airless lunar regolith, if not in a moist, carefully controlled studio environment? The answer lies in the unique properties of lunar dust. Unlike terrestrial sand, which is rounded and weathered by wind and water, lunar regolith is composed of fine, jagged, angular particles formed by billions of years of meteorite impacts shattering the lunar rocks. In the vacuum of space, these sharp particles interlock and compact together with remarkable cohesion, much like finely ground flour or talcum powder. Without any atmospheric erosion or moisture to smooth them, they retain their sharp edges, allowing them to hold their shape with remarkable integrity when compressed. The lack of moisture and atmosphere, far from preventing clear footprints, actually enables them to form and persist with an astonishing clarity. A recurring visual anomaly cited by critics involves the photographic crosshairs, which are etched onto the camera's reticle plate and should appear star on top star of every image. Yet in some Apollo photographs, these crosshairs appear to be partially or entirely obscured by objects in the foreground, suggesting to theorists that the images were doctored with objects pasted over the original film. This phenomenon, while visually striking, is a known characteristic of overexposed film. When a very bright object, such as a white spacesuit or a highly reflective surface, is photographed against a darker background, with a powerful light source like the sun, the intense light can bleed or bloom over the fine crosshairs on the film, making them appear to be behind the object. This is not evidence of digital manipulation, which was not existent in 1969, but an optical effect of film photography under extreme lighting conditions. The crosshairs are always physically star on star the film. Their apparent disappearance is an illusion created by light saturation. The absence of photographs depicting the Apollo command module re-entering Earth's atmosphere is another point of contention. Given the historic nature of the mission, why, skeptics ask, are there no iconic images of the spacecraft streaking through the sky, a fiery testament to its return? This lack of visual documentation, they suggest, implies there was nothing to photograph, because no re-entry actually occurred. The reality of atmospheric re-entry, however, makes such photography virtually impossible from the spacecraft itself. As the command module slammed into Earth's atmosphere at speeds exceeding 25,000 miles per hour, the friction generated immense heat, creating a superheated plasma sheath around the capsule. This plasma not only glowed intensely, obscuring any view from inside, but it also caused a complete radio blackout, preventing any external communication or remote photography. Even if a camera could survive the extreme conditions, the plasma would have rendered any image from within blurry and indistinct. Furthermore, no chase planes or ground-based cameras were positioned to capture such a fleeting, high-speed event from the ideal vantage point. The lack of such images is not an oversight, but a consequence of the harsh, unforgiving physics of re-entry. The muffled, sometimes indistinct audio transmissions from the lunar surface have also been seized upon as evidence of a staged event. Critics argue that the sound quality, at times, sounds artificial, as if recorded in a contained environment rather than the open expanse of space. The occasional pauses and clipped words, they suggest, are indicative of studio engineers editing and manipulating dialogue. However, the challenges of transmitting audio across nearly 250,000 miles in 1969 were immense. The communication systems relied on complex radio signals which were subject to interference, signal degradation, and the limitations of early satellite technology. The astronauts' microphones were voice-activated, designed to minimize background noise from their life support systems, which could lead to clipped words if they spoke too softly or paused abruptly. Furthermore, engineers on Earth actively filtered and processed the audio to make it as clear as possible for broadcast, a process that could introduce its own artifacts. The muffled quality is a testament to the technological limitations of the era and the vast distances involved, not a sign of a soundstage. Finally, a particularly tantalizing piece of evidence lies hidden in plain sight: reflections in the visors of the astronauts' helmets. In some close-up photographs, faint, ambiguous shapes can be seen reflected in the highly polished visors. Conspiracy theorists have claimed these reflections show studio lights, unusual equipment, or even a stagehand without a spacesuit, all pointing to a terrestrial set. These reflections, however, are a natural consequence of wide-angle lenses and highly reflective surfaces in a brightly lit environment. The astronauts' visors were designed to protect their eyes from intense solar radiation and provide a clear, unobstructed view, meaning they were highly reflective. Wide-angle lenses, used to capture as much of the scene as possible, inherently distort images at their periphery. Any object in the vicinity, the lunar module, other astronauts, equipment, or even the sun itself, could be distorted and reflected in the visor. Interpreting these ambiguous blurs as specific studio equipment requires a significant leap of faith, often driven by the desire to see what one expects to find. The reflections are not hidden clues, but optical realities of photography in an extreme environment. From the waving flag to the absence of stars, from the sea on a rock to the reflections in a visor, each piece of proof presented by the doubters, while compelling at first glance, unravels under closer scientific and historical scrutiny. The human mind seeks simple explanations, and the idea of a grand conspiracy can be seductive in its simplicity. Yet, the reality of the Apollo missions, the intricate dance of physics, engineering, and human endurance, is often far more complex and ultimately far more awe-inspiring. The anomalies, rather than exposing a hoax, often illuminate the profound challenges overcome by the men and women who dared to reach for the moon. For decades, the whispers have persisted, weaving a tapestry of doubt around humanity's greatest triumph: landing on the moon. We've all heard the claims, seen the grainy videos, and pondered the seemingly inexplicable anomalies. But what if the true, shocking evidence isn't a cover-up, but the overwhelming, meticulous proof of authenticity, hidden in plain sight, waiting for a deeper look? Tonight, we cut through the noise, beyond the sensational headlines, to confront these theories with the very forces that govern our universe: physics, optics, and irrefutable historical record. One of the most enduring images from the Apollo missions, and perhaps the most frequently cited proof of fakery, is the American flag seemingly waving in the vacuum of space. How, critics ask, could a flag ripple without air? The answer lies not in a manufactured breeze, but in engineering ingenuity and the unique properties of the lunar environment. When Buzz Aldrin planted the flag on July 20, 1969, during the Apollo 11 mission, it wasn't a standard fabric flag. It was specially designed with a telescoping horizontal pole sewn into its top edge, extending outwards from the main vertical pole. This bar was intended to make the flag fly proudly, even where there was no atmosphere to unfurl it. During deployment, the horizontal bar proved difficult to fully extend, leaving the flag bunched and creased. These permanent creases, combined with the momentum from its initial unfurling and the lack of air resistance to dampen movement, gave the illusion of waving. In the vacuum, those folds remained frozen in place, a testament to the lack of wind, not its presence. The lunar photographs are another battleground for conspiracy theorists. Where are the stars? They demand, pointing to the inky black sky devoid of cosmic glitter. This perceived absence is, in fact, a fundamental principle of photography. The lunar surface, bathed in the unfiltered sunlight of space, is incredibly bright. The astronauts and the lunar module were also brilliantly illuminated. For a camera to properly expose these brightly lit subjects, its aperture and shutter speed had to be set for a very short exposure time. Stars, even in the clearest sky, are incredibly dim compared to a sunlit landscape. Just as you wouldn't see stars in a photograph taken of a person standing on a sun-drenched beach during the day, the cameras on the moon simply didn't have enough time to collect light from the distant stars. They were there, as countless astronomers could attest, but they were too faint to register on the film under the necessary exposure settings. Another popular claim centers on the shadows. Critics argue that shadows in lunar photographs appear to run in different directions, suggesting multiple light sources, a telltale sign of a studio set. This argument misunderstands basic perspective. On the moon, the sun is the star-only significant light source. Just as parallel railroad tracks appear to converge in the distance, parallel shadows cast by a single light source will appear to diverge or converge, depending on the angle of the photograph and the terrain. The lunar surface is far from flat. Craters, hills, and undulations create complex shadow patterns that can easily mislead the untrained eye. Furthermore, the wide-angle lenses used on the Hasselblad cameras often create optical distortions that can exaggerate these effects, making parallel lines appear non-parallel at the edges of the frame. Every shadow, upon closer inspection, aligns perfectly with a single distant light source: our sun. Many find it perplexing that the lunar module, weighing over 15,000 kilograms upon landing, didn't create a massive blast crater beneath its descent engine. Surely a powerful rocket exhaust would churn up the lunar regolith. Here, the unique properties of both the engine and the moon's surface come into play. The LM's descent engine, the descent propulsion system, was throttled down significantly in the final moments of landing, reducing its thrust considerably. More importantly, the engine's exhaust plume in a vacuum behaves very differently than in Earth's atmosphere. Instead of digging a deep hole, the exhaust gases spread outwards in a wide, shallow cone, effectively scouring the loose lunar dust or regolith, star outward star, rather than digging star downward star. What little dust remained was simply compacted. Images from Apollo 11, 12, 14, 15, 16, and 17 all show the same shallow scour marks, consistent with an engine operating in a vacuum and landing on a fine, powdery surface. The infamous Van Allen radiation belts are often cited as an insurmountable obstacle for human spaceflight in the 1960s. These belts of charged particles, trapped by Earth's magnetic field, are indeed hazardous. However, the Apollo missions navigated them with careful planning and robust shielding. The Apollo spacecraft, particularly the command module, was constructed with an aluminum alloy that provided significant protection. More crucially, the trajectory through the Van Allen belts was meticulously calculated. The spacecraft passed through the most intense regions of the belts very quickly, typically in less than an hour, minimizing the cumulative radiation dose. The peak radiation exposure was equivalent to a chest X-ray, and the total dose for the entire mission was well within acceptable limits established by radiation safety protocols, comparable to what airline pilots experience over many years. The astronauts were not exposed to lethal levels of radiation, a fact confirmed by extensive post-mission medical evaluations and dosimeter readings. Then there's the sea rock anomaly, a photograph from Apollo 16 showing a rock with what appears to be the letter C clearly marked on it, suggesting a prop from a film set. While the image does indeed show something resembling a C, the most plausible explanation is far less sinister. Photographic anomalies such as a stray hair, a dust particle, or even a scratch on the negative or print can create such illusions. In the vast library of hundreds of thousands of lunar photographs, finding a single ambiguous mark is hardly conclusive evidence of a hoax. There are no other rocks with letters, nor any other evidence to support the idea of labeled props. It's a classic example of pareidolia, where the human brain perceives familiar patterns in random stimuli, much like seeing faces in clouds. The backgrounds of lunar photographs have also fueled suspicion. Some argue that the same distant hills appear in multiple photos, even though supposedly taken miles apart, suggesting a limited studio backdrop. This argument, however, proves the opposite. The phenomenon is known as a lack of parallax. When you move, closer objects appear to shift significantly against a distant background, while very distant objects appear to shift very little, or not at all. The lunar mountains are incredibly far away, often tens of kilometers from the landing sites. From the relatively short distances astronauts traversed, a few kilometers at most, these distant geological features would indeed appear almost stationary in the background, showing minimal or no parallax. This consistency across different photos, far from being evidence of a fake backdrop, is precisely what you would expect when photographing genuinely distant objects in a vast open environment like the Moon. The scale of the Apollo program itself, involving over 400,000 engineers, scientists, and technicians from numerous countries, makes a hoax logistically impossible. To orchestrate a secret of this magnitude, requiring the complicity of hundreds of thousands of individuals, many of whom would have to remain silent for decades, defies common sense. Moreover, the world was watching. Soviet tracking stations, British observatories like Jerdrelbank, and countless amateur radio enthusiasts around the globe were independently tracking the Apollo missions, listening to their transmissions, and verifying their positions. The raw data, the telemetry, the voice communications, it all pointed to one undeniable truth. These missions were happening in real time in space. Perhaps the most compelling and irrefutable evidence comes in tangible form: 382 kilograms of lunar rocks, core samples, pebbles, and dust collected across 6 Apollo missions. These samples, brought back to Earth by Apollo 11, 12, 14, 15, 16, and 17, are unlike any rocks found on Earth. They possess unique isotopic compositions, a lack of water-bearing minerals, and telltale signs of formation in a vacuum, under intense bombardment by micrometeorites and cosmic rays. For instance, lunar rocks are rich in isotopes like helium-3, which is rare on Earth but abundant on the Moon due to solar wind exposure. These samples have been analyzed by scientists in over 150 laboratories across more than 70 countries, including nations that were Cold War adversaries of the United States. Their independent analyses consistently confirm their extraterrestrial origin and their unique lunar properties. To fake these samples would require a geological and chemical deception on an unprecedented scale, one that would fool the entire global scientific community for over half a century. Beyond the rocks, there are the laser-ranging retroreflectors. These are passive mirror arrays, left by Apollo 11, 14, and 15, as well as 2 Soviet Lunokhod rovers. Since 1969, observatories around the world, including the McDonald Observatory in Texas and the Observatoire de la Côte d'Azur in France, have been firing lasers at these reflectors and timing the return journey of the light. This precise measurement allows scientists to determine the Earth-Moon distance to within a few millimeters, proving not only that objects were left on the Moon by these missions, but also that they are still there, reflecting lasers back to us today. This experiment, continuously conducted by independent scientific teams for over 5 decades, is perhaps the ultimate, ongoing proof of the Apollo landings. Finally, we have the photographic evidence from lunar orbit. Since 2009, NASA's Lunar Reconnaissance Orbiter, or LRO, has been mapping the Moon's surface with unprecedented detail. Its high-resolution cameras have captured images of all 6 Apollo landing sites. These images clearly show the descent stages of the lunar modules, the scientific instruments left behind, the tracks of the lunar rovers, and even the faint, unmistakable trails of the astronauts' footprints in the lunar dust. These aren't blurry, ambiguous images. They are sharp, undeniable photographs, independently verified and publicly accessible. The LRO's precise orbital data also allows for the exact pinpointing of the retroreflectors, correlating perfectly with the laser-ranging experiments. The narrative then shifts from the speculative to the concrete. The shocking evidence NASA doesn't want you to see is in fact the overwhelming body of proof, freely available and meticulously documented. It's the thousands of hours of film, the hundreds of thousands of photographs, the millions of data points, and the tangible lunar samples that have been studied by generations of scientists. It is the testimony of hundreds of thousands of individuals who dedicated their lives to this monumental endeavor. The true marvel isn't a conspiracy, but the audacity of humanity's ambition, the brilliance of its engineering, and the courage of its explorers. The moon landing was real, a testament to what we can achieve when we unite under a common, impossible goal. The evidence is not hidden, it is etched into the very fabric of our scientific understanding, and into the dust of another world. For decades, the very idea of humanity reaching another celestial body has been a source of both profound inspiration and persistent skepticism. The whispers of doubt, the intricate theories of deception, they swirl around one of our species' most audacious achievements. But beyond the shadows of conjecture, beyond the intricate debates fueled by grainy photographs and misinterpreted physics, lies a truth far more compelling, a narrative woven not from conspiracy, but from courage, intellect, and an unwavering belief in the boundless potential of humankind. This is the story of Apollo, not as a subject of controversy, but as a testament to what we can achieve when we dare to dream beyond the horizon. It was an era defined by Cold War tensions and a fierce space race, a global competition that pushed the boundaries of what was thought possible. On May 25, 1961, President John F. Kennedy stood before a joint session of Congress and declared a national goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth. At that moment, the United States possessed only 15 minutes of manned spaceflight experience. The challenge was monumental, bordering on the impossible, yet it ignited a spark that would illuminate the path to the stars. This wasn't merely a space program. It was a national crusade, mobilizing an unprecedented intellectual and industrial effort. The scale of the Apollo program was staggering. Over 400,000 individuals across the United States contributed, from engineers and scientists to seamstresses and technicians. They worked in tandem, a vast orchestra of human ingenuity, each playing a crucial role in a symphony of innovation. Consider the Saturn V rocket, a towering marvel of engineering, standing 363 feet tall, taller than the Statue of Liberty, and generating 7.6 million pounds of thrust at liftoff. Its sheer power was an echo of the collective will driving the mission, or the Apollo Guidance Computer, a technological cornerstone designed by a team led by Margaret Hamilton, whose pioneering work in software engineering laid the groundwork for modern computing. Every component, every line of code, every calculation was a step into the unknown. The journey to the moon was not a single, isolated event, but a meticulously planned series of missions, each building upon the last. Apollo 8 in December 1968 became the first human flight to orbit the moon, offering humanity its first glimpse of Earthrise, a fragile blue marble suspended in the vast blackness. This iconic image, captured by astronaut William Anders, transcended national boundaries, fostering a nascent environmental consciousness and a profound sense of our shared vulnerability on this pale blue dot. Then came Apollo 11, on July 20, 1969. Neil Armstrong and Buzz Aldrin stepped onto the lunar surface, marking an indelible moment in human history, while Michael Collins orbited above, a solitary sentinel. The scientific bounty reaped from these missions was immense. Across 6 successful lunar landings between 1969 and 1972, Apollo astronauts collected 382 kilograms, 842 pounds of lunar rocks, core samples, pebbles, dust, and soil. These precious samples, meticulously catalogued and studied by scientists worldwide, revolutionized our understanding of the moon's origin, its geological evolution, and its relationship to Earth and the early solar system. They confirmed the moon's ancient, volcanic past and provided crucial evidence for the giant impact hypothesis of its formation. Beyond the rocks, Apollo left a legacy of scientific instruments on the lunar surface. The Apollo Lunar Surface Experiments Package, ALUSEP, included seismometers that recorded thousands of moonquakes, providing insights into the moon's internal structure. Laser-ranging retroreflectors, RRR, allowed scientists on Earth to precisely measure the distance to the moon using laser beams, confirming its gradual recession from Earth and providing a highly accurate test of Einstein's theory of general relativity. These instruments, some still functional decades later, are silent witnesses to the scientific rigor of the Apollo program. The technological advancements spurred by Apollo didn't remain confined to the vacuum of space. They permeated nearly every aspect of modern life. The necessity of miniaturizing electronics for spacecraft led to the development of integrated circuits, paving the way for the personal computer revolution. The precise navigation and control systems developed for Apollo contributed to GPS technology. Even seemingly mundane items owe their existence or refinement to the space program. Freeze-dried foods, advanced insulation materials like mylar and aerogel, memory foam, cordless power tools, improved medical imaging, water purification systems, and even the smoke detector. These are just a few of the countless spin-off technologies that originated from the intense research and development driven by the lunar objective. The demands of human spaceflight, particularly the need for robust life support and monitoring systems, pushed medical science forward. The development of miniature sensors, remote monitoring capabilities, and advanced surgical techniques all benefited from the relentless pursuit of astronaut safety and well-being. The very ethos of problem-solving under extreme constraints fostered an environment of innovation that continues to yield dividends today, far beyond the confines of space exploration. Apollo wasn't just about reaching the moon, it was about pushing the boundaries of human capability, and in doing so, enriching life on Earth. Culturally, the moon landing was a unifying global event, transcending political divides and inspiring a generation. For a brief shining moment, humanity collectively held its breath, then celebrated a shared triumph. Neil Armstrong's immortal words, "That's one small step for man, one giant leap for mankind," resonated across continents, capturing the profound significance of the moment. It sparked an unprecedented interest in science and engineering, encouraging countless young minds to pursue careers in STEM fields, laying the groundwork for future innovations and explorations. The image of the Earth from space, a fragile blue marble, fostered a new perspective on our planet, highlighting its beauty and vulnerability, and laying the groundwork for the modern environmental movement. Yet, despite this overwhelming body of evidence, the shadow of doubt persists. The moon landing hoax theories, often fueled by misinterpretations, selective evidence, and a fundamental distrust of authority, continue to circulate. These theories, no matter how elaborate, fundamentally undermine the principles of scientific inquiry and critical thinking. They challenge not just a single historical event, but the very methodology by which we collectively ascertain truth. Maintaining factual accuracy against persistent misinformation is not merely an academic exercise, it is crucial for the very fabric of scientific progress and public trust. When verifiable facts are dismissed as elaborate hoaxes, it erodes the public's confidence in science, in institutions, and in the shared reality that underpins a functioning society. It stifles the curiosity and wonder that drive discovery, replacing it with cynicism and suspicion. The evidence for the Apollo missions is not just circumstantial, it is multifaceted and independently verifiable. International tracking stations across the globe, including those in the Soviet Union, monitored the Apollo flights. Thousands of individuals, from engineers in Houston to optical tracking specialists in Australia, were direct witnesses. The lunar samples, analyzed by laboratories worldwide, are demonstrably extraterrestrial and consistent with each other. The Lunar Reconnaissance Orbiter (LRO), launched by NASA in 2009, has photographed the Apollo landing sites, revealing the descent stages of the lunar modules, astronaut footprints, and even the tracks of the lunar rovers. These images are publicly available, offering irrefutable visual confirmation. To dismiss the moon landing as a fabrication is to disregard the immense effort, the collective genius, and the undeniable triumphs of an entire generation. It is to deny the inspiration that propelled countless individuals into careers in science, technology, engineering, and mathematics. It is to diminish the profound cultural impact of seeing our species extend its reach beyond its home planet, fostering a sense of shared humanity and a renewed appreciation for our place in the cosmos. The legacy of Apollo is not just etched in lunar dust. It is woven into the very fabric of our modern world. It is a beacon of what humanity can achieve when united by a common, ambitious goal. It reminds us that the greatest leaps forward are often born from audacious challenges, from the willingness to confront the unknown, and from the relentless pursuit of knowledge. As we look towards future endeavors, returning to the moon, venturing to Mars, and exploring the farthest reaches of our solar system, the lessons of Apollo become even more vital. They teach us that progress demands rigor, transparency, and an unwavering commitment to truth. They remind us that the spirit of exploration is an intrinsic part of the human condition, a fundamental drive to understand our universe and our place within it. The moon landing was not a trick of light and shadow, but a genuine triumph, a testament to our ingenuity, our courage, and our enduring capacity for wonder. It stands as a powerful reminder that while the universe may be vast and mysterious, humanity's spirit of exploration is even vaster, an eternal flame guiding us toward the future, a future we build not on whispers of doubt, but on the solid ground of scientific truth. Thanks for watching Study Z. Remember to subscribe for more deep dives.